Awesome. I think we're past the top of the hour, so I'm just, without any further ado, I'm just gonna let you do your thing.
Perfect. Awesome.
Also, for any late joiners, Magnus cannot host this session because of a family issue, and so I'm stepping in and basically introing the session and then just muting myself. So that's what I'm doing today. Welcome, Mark.
Thank you, Daniel. Hello, everybody. Welcome to my session. If you do have any questions, pop it into chat, shout out, whatever you want to do in there, all right? So I take it you can all see my slide in there. So to be honest, I'm going to largely skip past the introductions, really. Working with Microsoft data for a long, long time. Today, anytime I'm doing a presentation, I like to kind of have a business requirement, as in, kind of what actually am I trying to solve with this technology in there, okay? So this is a real business requirement, but it's an old business requirement, all right? And it was way back in 2012, 2013. A company approached me with the need that basically wanted to capture your phone, okay? When you walk past the shop, you've got a MAC address on your phone. Your phone is continuously looking for Wi-Fi signals, Bluetooth signals. Routers actually automatically see this, even if you don't register on the Wi-Fi. And as a result, you can actually capture the fact that, oh, a phone was near this Wi-Fi zone. And that you can convert that into insight. So you can get kind of interesting things like how many people walk past your shop, how many people are in your shop, stuff like that, okay? And a lot of this tech has moved on massively since. A lot of that is native functionality built into routers now, but at the time was more kind of a bit unusual. Right. But anyway, it was interesting. So I developed a system. How many people pass by your shop, footfall. They also, I suppose, wanted to react to live data. They wanted a system that could kind of go, oh, something's happening, do something. Okay. So if you're looking at this requirement, you could say potentially you got a large volume of data. All right. Because if this company, who, by the way, went bankrupt, but nothing to do with the technology, they could potentially have onboarded, say, a significant amount of customers. So suddenly you get a lot more volume coming in on a very, very short notice. And also they wanted to have the ability to react to incoming data. We would basically now call that streaming. Okay, that's streaming data. Okay, so this is what we built at the time. It was all SQL Server based, which was a bit of a pain. Basically, there was a router. The router sent it on to a web service. .NET Web Service, dumped it onto a file share, and then we had integration services running over those files all the time, loading it into a SQL database, and popping in front of that, we had a reporting service report. There's a lot of movement. There was a lot of development in there because, SQL Server isn't really designed to handle that volumes coming in all the time. So you're putting a lot of work into your integration services packages to kind of handle that and also to do the analysis. Okay. And then on top of it, you're putting into a VM, and you had FTP and IAS and operating systems and patches, lots of stuff going on there. But we got the system up and running, the system existed. Okay. So fast forwarding, I thought it would be interesting. Well, how would I approach that now? Okay. How would you approach this solution? So let's talk about streaming data capture, because that's what I had. I had a stream of files coming into me. So one of the V's of big data, all right, one of the 5 V's, and it's kind of more in the whole velocity area, all right? So velocity, the speed at which data is generated, data that arrives continuously where you want to perform analysis on it as it arrives. That's the key call out of streaming data, arrives continuously and you want to perform analysis. Data arriving continuously isn't really a problem if you're going to batch load it at the end of the day. You just have to store it somewhere, right? But when it arrives continuously and you want to analyze, you got to do something else. That's where your streaming kicks into play. So now my new solution would look a little bit like this, all right? So we would have a router still. The router this time will be sending it to an event hub. So we have to write an ISS web service, but now we've got an event hub, an Azure event hub that we can send stuff to, all right? And an event hub basically receives messages and holds the message and passes it to somewhere else, but receives and holds messages is what an event hub does. A stream analytics job can then connect to that event hub and take the message, do a little bit of work in it, do a little bit of analysis on it, And then after that, well, you can kind of do what you want, but in my case, I'm just going to put it into an Azure SQL database and foreign services or something like that in the front if you wanted to. This all, of course, now is Azure functionality. So it's all platform as a service things as we pop them in there. All right. So having a look at this in there, I'm going to be talking about event hubs and stream analytics. Because the SQL Server side is straightforward. Okay. So that's what I'm talking about. Let's have a demo. So I'm going to show you what I have built in here. All right, got a few different bits and pieces. Let's look at the end result. And the end result is kind of rather boring, okay? Oops, I shouldn't have hit new query. Apologies about that. Let's just see how many rows of data exist in this table at the moment. And over here, I've got a C# bit of code that is continuously sending messages to an event hub at the moment. You can see them streaming up there, okay? And I'm just pretending to be a MAC address at the moment, okay? So that's happening. That's something that's on my that's not something that's on my VM in C#. It's just impersonating a router, okay? What's happening out the other end is this. So we'll note that figure in there. At the moment, we have 6 odd million rows of data inside that database. Super. Let's run it again. That'll take a few seconds to run, and let's see, does it go up? And while I'm doing that, let's show the basic things that have been built. We've got an event hub over here inside the Azure portal. All right. If I go clicking on that event hub, I can see that there are events coming in. Okay, we're going to see a little bit more about this in a while, but there's events coming in. This is certainly active. All right. We'll go back to my plane, and the other thing I have in here is a stream analytics job. So I'm going to click on that. And if we look at its utilization, we see down here that there is stuff happening on my stream analytics job. Okay. There's actually 2 events happening there. That blue line is incoming event, and that orange line is outgoing event, events that have done with something. And if I look over here, I can see there's a utilization going on of just under 25%. So something is happening on my stream analytics job. So there are the 2 things happening. And let's just see what the result is. Okay, so that query is run there now. And if we have a look at that, you can see how there has been another 10,000 odd lines of data put into my SQL Server. Okay, so that's actually all I'm going to demo. The rest is going to show you how you build that. Okay, so I still will be demoing, but that's actually the solution. We won't bother with the report and service side of things. It's just a report, right? But this was captured. Let's have a quick look at what's in it, just to show you the type of data I'm capturing. Okay. Topic 100, interesting. Topic really wants topic group. Top. Okay, so this is just a quick sample of data that I'm capturing in there at the moment. And really all I'm seeing in here is I'm pretending to be an access point, I'm pretending to be a MAC address, and then I'm classifying that MAC address into whether it's a visitor or passerby. And I'm classifying that by a rule, okay? And the rule is how frequently have I seen this MAC address in the past 20 seconds, I think, okay? And based upon that, if it kind of goes, okay, if I've seen it more, I think my cutoff is 6. If I've seen it more than 6 times, I kind of go and it's a visitor, otherwise it's a passerby. Okay, so I'm just kind of mimicking what would be happening on my routers in here, seeing MAC addresses all the time. And again, that's just the stream of data that's been coming into me all this time. All right. So that's my basic demo. All right. Let's pop back to PowerPoint shortly. Demo. What makes this work is something that we call a windowing function. All right, the event hub has received a message and it's held it. The stream analytics job has come along, connected to the event hub and said, hey, give me a bunch of messages. And it does a little bit of analysis on that. And that bit of analysis is a SQL statement. Okay, but it's a SQL statement that uses something called windowing functions. Look at them. Window functions allows you to analyze streaming data and it segments it into temporal windows, which is a very, very Star Trek-y sounding word. So basically, it chunks up your stream into time boxes, and then have a look in that time box and goes, this is what I see in this time box, and then it repeats for the next time box and the next time box. Events over time. We have got 5 windows. We have a tumbling window, a hopping window, a sliding window, a session window, and a snapshot window. All the rest of the images you're about to see come from Microsoft Docs. So that's the URL if you want to go checking it out in there. But basically, we're going to explain Windows via tweets. And then we're going to demo Windows. So window and functions explained via tweets. Tumbling window. The number of tweets that have happened every 10 seconds. Otherwise, it would look like this. So here's my timeline. Here's a tweet. It's a 10-second tumbling window. So after 10 seconds from when time starts, it creates a window, looks back and says, hey, I've got 5 tweets in this window. It then continues on, waits another 10 seconds, creates another window, looks back and says, oh, I've had 2 tweets in that window, and continues on. And inside this window, it sees 4 tweets. So a very basic tumbling window, just basically kind of goes 10 seconds, 10 seconds, 10 seconds. Obviously, 10 seconds can be 10 minutes, 10 hours, different intervals can be put in there. Hopping window. The hopping window. Count the number of tweets in the past 10 seconds and do that every 5 seconds. The same tweet stream, all right, except our first window kicks in after 10 seconds, like the first time, and it looks back and it sees, oh, I've had 5 tweets. But then 5 seconds later, another window kicks in and it looks back 10 seconds and it sees, well, there's 3 tweets inside in that window. Then another 5 seconds, it looks back, see there's only 2, moves forward, looks back, sees there's only 4, moves forward, looks back, sees that there's 4. So still a 10-second window, but it's hopping and it's doing it every 5 seconds. Okay? Sliding window. Count the number of tweets that occurred in the past 10 seconds from when a tweet arrives or is past 10 seconds ago. All right, sounds a bit complicated. Basically, more looking for events that happen in there. Okay, so an event happened, a tweet arrived, so it counts the number of tweets that have happened in the past 10 seconds, and there has been 1 tweet happened in the past 10 seconds. Then here another tweet arrives, so it looks back 10 seconds and it sees there's 2 tweets. Over here, 2 more tweets arrived, looks back, now there's 4 tweets in the window. Now what happens here? Because a new window is being generated, but a new tweet wasn't created. Now what's happened in this window is that this tweet up here has fallen out of the window. And that's what it goes from when a tweet arrived or is past. We move forward again. What happened here? Again, no tweet arrived, not at that time. But if I look back at the start of the window, I can see more tweets have fallen out. So 5 has fallen out, so I'm down to 7 and 9. And then here a tweet happens, so a new window is generated again. And however, at the same time, those have fallen out of the window, so there's 1 window that covers this. And then over here, nothing happens, but 1 more window gets generated because that last tweet fell out of the window. So it's sliding, it's moving around, kind of going, who's come in, who's left. Something's left, create a window. Something's arrived, create a window. Session window. Count the number. For some reason on Microsoft Docs, they changed the minutes here. Okay. Count the number of tweets that happened within 5 minutes of each other over a 10-minute period from the first tweet. So it would look like this. A tweet happens, so it starts counting. And another tweet happens. It continues counting because that tweet happened within 5 minutes of each other. And then it continues on, and my window closes because no more tweets have happened. Over here, I get a longer window. A tweet happened, so the window starts counting. Another tweet happens, so the window continues. Another tweet happens, the window continues. Another tweet happens, the window continues, etc. until this tweet, when the window continues, no more tweets happen, and it closes. And then out here, we have a random singleton on its own, where a tweet happens, so it counts to see what, so a window is created, and then 5 minutes later, the window closes. So much more kind of a cluster in effect. Okay, a whole bunch of things have happened, so extend my window because I'm interested in this cluster for a predetermined time, and then close it off. And that's my analysis period. And then there's the snapshot, and the snapshot window is slightly different. Count the number of tweets that happen at the same time. Okay, so in this case, in here, a whole bunch of tweets happen here, equals that's a window. Something happens here, that's a window. Something happened here, that's a window. Something happened here, that's a window. So it's very much bang, right now, this is my window because something has happened. Okay, so let's look a little bit at window and functions. Okay, so back into my window function. I should have done this earlier. I'm going to stop my Stream Analytics job, and it does take a minute to stop the job. Okay, so while that's stopping, I'm going to pop back in here, and let's have a quick look at the Event Hub for a second. Okay, so the Event Hub has been generated away. Event Hub is a relatively simple thing to set up and run. It comes in two flavors, standard and basic. I'm running on a basic at the moment, and it's got this thing called scale, called a throughput unit. Okay, which is just how much volume of data it's going to take, and we can scale that as well. We'll be seeing a little bit more of it going on. Apart from, I've got my message that my Stream Analytics job is finished, so let's jump in there. All right, let's break down the Stream Analytics job. Okay, there's three key parts. I had four of them. There's three key parts of Stream Analytics job, and often there's a fourth part to a key analytics job. And they're all in this section over here. Inputs, functions, queries, and outputs. Okay, a Stream Analytics job needs an input. So let's have a look at it. Now I've got a couple of inputs inside the Stream Analytics job, so we're not limited to one. All right, let's have a look at more, and let's have a look at what we can do. And this is where I can get an input from an Event Hub, an IoT Hub, or Data Lake blob. All right, so that's what it can monitor. It can monitor those areas for an input. Okay, you can see how I've got a couple of different ones set up. They're all coming from an Event Hub. I can also add in a SQL database, but that's not a stream. I can use that for what we call reference data. So if I'm bringing in a stream of data and I want to combine it with something, basically a join, right? I want to combine it with something, say, in a SQL database, then I can create that as a reference data. There's reference data in the SQL database over here or in a blob storage. So that's the input. You're also going to have an input. You're also most likely going to have an output. Okay, so let's look at the outputs. In this output, I've only got one. All right, it's a SQL database. But if I wanted to add on more outputs, we can see there's a few more options in here. Okay. I can output to another Event Hub, to databases, to storage, to Cosmos, to Power BI, to Synapse, etc. So various different parts of the ecosystem I can put my output. Okay, super. And then the bit in the middle, that's my input, that's my output. There has to be something in the middle to make it work, and that's the query. So click on query, and here's my query at the moment. All right, and actually I've got lots of queries, but this is the query that had been running. All right. And it's a SQL statement, all right? But a SQL statement with a couple of special things. First of all, into this. So it's inserted into Stream Analytics demo. That is not a SQL table. That is my output that I defined in my Stream Analytics job, which happens to be a SQL table, okay? That can get a little bit confusing at the start. People go, why can't it see my SQL table? You're not creating... When you create an output, you're not creating an output to a database. You're creating an output to an actual table. So then you just reference that output. Okay, but it's pretty straightforward. It should basically be in your output list. So select into this output. Where do I select from? I select from console source. Okay, and console source is my input. Okay, so you're writing a SQL statement that references your inputs and outputs like it's just a table inside a SQL database. Then up here, you've got the group by, and there's my tumbling window, a session window. Okay, and the rest of it is just some basic analysis. So all I'm doing is I'm capturing the time, and capturing the access point, my MAC, and here's my little bit of logic. Okay, if I see it more than 5 times, then it's a visitor, otherwise it's a passerby. And I'm also doing a random count on how many times I've seen something in here as well. Okay, so that's my basic bit of analysis to make that as complicated as suits your needs. But the key part is into an output from an input. Okay, is your construction with your tumbling window going down there. Let's talk about that fourth thing, which is optional but very interesting, which is a function. Now, I don't have any functions set up in here. But if I go to functions and add a function, you can see in here that I can reference to ML or JavaScript. All right. This is where you will be, if you had some little bit of cognitive services analysis stuff going on, this is where you'd be putting it in. Say if you're doing something like fraud detection and you had something in particular to kind of go, if this type of thing happens, check it. But maybe it's not something you can put into an if statement or a case statement, but it's actually an ML experiment that you have behind it. So actually, you would pass, once you create a function in here, it actually becomes accessible to the SQL statement. And inside your SQL statement, you can basically kind of go, okay, select function reference, put in your data, it will call ML, it will pass back a result, and then you have that directly embedded as part of your stream. So very much cognitive services reacting to data in at a time. I don't have it set up in here, but it's quite interesting. So that's the basic construct of a stream analytics job. Let's have a look at those tumbling windows in there, okay? So, right, what I got to do is I have got to, excuse me a second, I'm just going to uncomment this, comment this guy out. All right. And let's look at my first one. Okay. And I want to upload some sample data. Okay. I could actually just query the stream. You can actually see it down there, right? You can see that there's data in here, but I just want to load up sample data. So I've got a very simple bit of sample data. And this is what it is. There are only 7 rows of data in here. Okay. So let's look at what I have, right? I'm pretending to be a MAC address in here. So I've got a MAC 11 and I have another MAC called 12. All right. And I've got a timestamp in here as well. All right. So if I look at a timestamp, this happened at 41 seconds. This happened at 46 seconds. This happened at 49 seconds. And this happened at 55 seconds. And then there's another one up here that happened a minute later. Okay, 55 seconds, but 1 minute later. And then this MAC is a new MAC address, and this happened at 13 seconds, and then this happened at 15 seconds. So I'm pretending I'm seeing something, okay? So if I was to put on my analysis head in this one, I would kind of go like, well, this looks down here. They're all really close to each other. This probably is a visitor, okay? This next row, while it's the same MAC address, it's a little bit later on. I'm going to think maybe they've left the shop at that stage, but maybe they're in the forecourt or outside, you know, might not be in the shop. And then this guy up here kind of going, well, okay, I definitely saw them, but I only saw it twice. So I'm not going to count that. Okay. So this is how I kind of want to analyze that data a little bit in there. Okay. So let's start that with my first bit, which is that's just a basic copy. Turn off the basic copy. We don't want to do that. We know how a copy works. Turn on a tumbling window. There's going to be some questions asked that you're going to chat in a minute. Okay. So test that query. Okay, running that query. So this is running a tumbling window every 10 seconds. Okay, so remember back to what we were saying, 10 seconds, 10 seconds later. Okay, and this is the summary of the results. All right. So it's turned around and kind of went, well, okay, hang on a second. At this period, 4050, I saw this MAC address and I saw this MAC address 3 times. So my logic is, and in this demo is, oh, if I see him more than twice, it's a visitor. So it classifies it as a visitor. Then in the next window, 10 seconds later, also sees that MAC address 11, but only sees it once, so it's a passerby. And then down here, different MAC address appears, sees it twice, so classifies a passerby, and then later on sees one more window with that one MAC address, still a passerby. So this is kind of close to what I would kind of expect out of it. It has correctly classified this guy as a passerby, but then it's kind of got this rogue little guy, which we would say, well, that was actually the same incident. So not bad, but let's see what the other windows will do for us. Okay, so that was the basic tumbling window. So now let's move on to a hopping window. So the hopping window is again a 10-second window where it repeats it every 5 seconds. Okay, so let's test that and see what the results are like. So now we get more data. Okay, so remember I got 7 lines of input and the first query gave me 4 lines of output, but now I got actually as much input as I have output. All right, and if we follow the thread, we got a first window at 45 seconds, then at 50, then at 55 seconds, then at 00, and then it moves on a bit, and then we see another 5 seconds, 5 seconds, 5 seconds. So the gaps are in there. So an event happened, it took its first 10-second window, but then 5 seconds later it repeated that window. And if we look at the output of that, we kind of go, okay, well, I saw him as a passer. I only saw him once in this window, but now suddenly in this window I saw him 3 times. So it's a visitor. And then in the next 5-second window, still there, so still a visitor. And then becomes passerby. Then a new person comes in, passerby, still passerby, and they're all passerbys. It's a lot more verbose actually in this case. It's captured a lot more information. It's done over analysis, right? It's basically kind of almost like the equivalent of a person standing at the door, kind of going, he's in the shop. He's still in the shop. Okay, that's kind of what the hopping window is doing for me. So not too happy with that one. Let's go to my third case. And this is my sliding window. So this is when it comes in or leaves the exit, or leaves the window, all right? So let's just test that query. And now we get more rows of data in my output than I had on my input. I had 7 rows of data on my input, and now I've got what, 9 or 10 rows of output. Why has that happened? Lots of stuff going on, lots of events, because remember this is as stuff goes into a window and exits my window. So let's look at my window. My window is a sliding window on 10 seconds. So I'm seeing something happened on 41, correct. We saw a MAC address at 41. Something happened at 46, something happened at 49, something happened at 50. In each one of those cases, it's then going, well, let's generate my 10-second window, all right? And as a result, I'm seeing this kind of thread where I have the MAC address as passerby, still a passerby, now classifies as a visitor, but now goes back down to passerby. Why? Because one of those dropped out of the window. However, then appears again, so it's now reclassified as a visitor, and then begins to drop out, and then begins to drop out, and gone, and gone, and gone. Very, very shouty is how I describe it. It's like this time the guy at the front door, instead of telling me you have a visitor and staying quiet, he's kind of going, you have a visitor? No, he's not a visitor anymore. Oh, now he's a visitor again. I can still see him. No, going, still see him. He's gone now. Very, very, like lots of information being thrown at you going on there. Okay. So again, for what I want in here, not sufficient. Or too much data going on. So let's try the next window. The next window is my session window. My session window was something's happened, continue the window, and if another event happens in that window, keep continuing the window until it closes. So let's run that. And now look what's happened. So my session window is 10 seconds, extending up to 20. And I see in here, well, a MAC address arrived, classified as a visitor, and I'm seeing 4. So it actually all fell in that first 10-second window happened, but it extends out the window. And by extending out the window from the last event, it brought in the 4th event into that window and wrapped it all up as a kind of going, well, this is one window, so this is what I see. And then later on, we have my guy who was seen here twice, and that's the seen twice. And then that little rogue one at the end where maybe appeared. But this is the same analysis that I would have come up with when I looked at those rows of data. That's exactly how I would have classified it, and that's what I got out of it. So for this experiment, it looks like this is probably the window I'm going to go with. I'm going to want to just show you the last function. Overall for 5 types of windows. And on this one, Pop quiz, pop it into chat. What do you think this will, how many rows of data will this output, do you think? Bearing in mind, I've got 7 rows of data on the input, and the definition of the this window is when something happens. 7 rows, bang on. Thank you, Daniel. I hope, yes, because all of them were all unique. So it's just kind of going bang, this happened, this happened, this happened, this happened. Okay, so that's what's going on there. Okay, so super. So what I'm going to do, that's my hop in Windows. I'm just going to kick off the stream again. So in my stream, in my demos running to start, this actually is my window that I'm running, and all that's really happened is I've just increased the amount of people that I'm doing it for. Okay, I can run a test in that query if I wanted to test. It will give me a slightly different output potentially. No, pretty much the same output going on there. That's fine. And we're fine. Okay, so let's go back to my job and let's start up my job. But let's note a couple of things that have happened in Stream Analytics world. This to begin with, okay, dropped off the edge. Now, let's just see. No, actually, as it happens, my job is also, oh no, my job is still running as well. So my router is still sending data, okay? But I've turned off my Stream Analytics job, and I can see in here that, okay, there's no more events coming in, and my resource utilization is now sitting there at 20%, and that ... basically means it's doing nothing, all right? So have I got a problem here? Have I lost data? What do you reckon? Put it into chat. Have I lost data? Have I got an issue? What do you think? All that data, in the last 5 minutes that I've been chatting, have I just lost a whole slew of data? And the answer is no. Okay? No, because it's in the Event Hub. So the Event Hub has been running that whole time. Okay? So here's my Event Hub. It's still been receiving its data. Okay? Note here, the outgoing has dropped because it's nowhere to put it at the moment. Okay, nobody's looking for the data, but the Event Hub is still receiving that data. Okay, so in comes data into the Event Hub. The Event Hub is just, remember, it receives messages, it stores messages until somebody does something with the messages. It won't store forever, by the way. It's 1 day or 7 days, depending on which version of Event Hubs you're on, okay? But it will store it. So if I go back to my Stream Analytics job, and start that up again, I now get a choice. Okay, I can start it from now or from when last stopped. So when I want to bring in all that data again, I'm just going to go from when last stopped in this case. And that will crank up my Stream Analytics job, and we should start seeing data coming in again. Okay, so that'll take a couple of minutes to start up. Let's go back to my PowerPoint for a moment. I really should have one of those fancy stream decks. Let's talk a little bit about cost while that job is starting up, all right? Because it's kind of how much does this all cost? Database, let's forget about the database. It's a database from €5 a month. The Event Hub. Basically, you can get a basic version for €9 a month per TU throughput unit, max 20 throughput units. And then you get a standard for €18 per month per throughput unit. There's also a dedicated version of it in there as well, and there's also a charge on ingress events in there per million events. For the Stream Analytics, there's standard and dedicated. Okay, dedicated, you have to have 36 streaming units minimum. If you go on standard, you can start from 1 streaming unit and go up to 192, I think. Streaming units start from 10 cents per hour, which works out around €75 a month. So a very basic streaming solution basically is going to be €75 a month plus that $9.23 a month. And after that, it's kind of a case of how much capacity do you need in there. If you went up to 192 streaming units, that would be 15,000 a month. That's a lot of capacity. Let's talk a little bit about performance and scale. Okay. Event Hub streaming. Again, I'm not going to talk about the Azure database because there's far better people out there to talk about Azure databases. There's probably far better people to talk about Stream Analytics, but you're listening to me. three key areas: the event hub, the stream analytics, and the database. We'll look at the first two. If we look at the event hub, we got a namespace, basic and standard. This is where you set up your basic and standard. There's some limits around it in terms of the number of consumer groups and broker connections. Standard and basic just have more connections, got a longer retention policy in there. You can change that, however. You can start with basic, and if you need standard, you can change it in. You then turn around and set up a number of partitions that you create inside in that event hub in there. Okay, and this really aids downstream concurrency of what systems are picking into it. You cannot change it. And then the number of throughput units. And a throughput unit is the key thing. It's 1 megabyte a second or 1,000 events a second. So if you've got 100 messages a minute coming into you, 1 TU is loads, right? But if you're sending in images, okay, that are going to take big files in there or whatever's wrapped into it, then you have to look at it. All right. You can change this manually, or you can set it to auto-inflate. If I look at the stream analytics job, they classify it by a streaming unit of 1 to 192 streaming units. And they describe a unit as a unit of CPU and memory without necessarily telling you how much you get. But each SU can roughly process 1 megabyte per second. So if you remember back on my event hub, I had a TU throughput unit, and you could have max 20, and it also was 1 megabyte a second. Over here in the streaming unit, I can have 1 megabyte a second, but I can have 192 of them. So if you kind of go, why the hell do I need 192? All right, that's down to the SU efficiency, and it's affected by lots of things. Primarily the window and functions and the cardinality of the data you're looking at. Okay, so how complex is your window and function? What is the grain of your data? Okay? If in your function you have complex query joins, I mean, I have a very simple query going on there, but if you're ripping apart some JSON messages and doing things, you can kind of get some funny joins going on there, and that adds to the cost. How many partitions can actually have an impact upon the streaming unit efficiency? If you call UDF function JavaScript runtime, there's an instantiation associated with that one. If you use reference data, okay, so if you're bringing in data on a stream, but then you're kind of going, oh, I'm doing a quick lookup in an Azure database to join data, then there's a cost associated with that as well. Basically, you can have lots of things that will actually impact the efficiency of your unit in there. Okay, so my demo architecture. All right, so this is my demo in there. It's roughly 100,000 events a day happening in there. So if I break down 100,000 events a day, 60 events a minute, 1 event a second, 1 analytics, 1 SU. That's my cost. That's how it's all going to work out in here. If I was to leave this job, run away, that's all I need on it. Demo, we are going to talk about just have a flash at look at some of those things that we're just talking about, all right? So my streaming is still happening, which is great. I go in here and do a quick reach here. So we can see now, okay, on my monitoring, my utilization has jumped on up. Okay, now bear in mind, it was playing catch up there, so it took in a lot more data. But actually, interestingly enough, from a utilization point of view, this didn't change that much at all. All right, and my events are still coming in. If I go to my event hub, there's been no change in here, except we can see the big jump up on the throughput because it started offloading all that data into the streaming unit. Now, what happens if I turn around? I can make a dynamic change to this. So I could pop this up to 5 throughput units at the moment. Okay, and that will kick in. So now basically I should be able to take in more data if I'm sending it, if it's sent into it. All right, so that impact has changed on there. And I could also turn around and kind of go to my streaming job and go, okay, I could scale it. Now I can't scale it while it's running. I would have to turn that off, scale it up, and then start it up in there again. Okay, or put into full parallel mode in there as well, obviously. But instead of doing that, because it takes a few minutes for those things to swap and change and chop around, I'm just going to talk you through some image captures of what you'll actually start seeing in there. All right. So this is a little graph of my streaming unit utilization percentage. All right, so this is my SU. And you can see in here, this is when I was sending in 10 concurrent by 100 messages and 100 sends in a copy operation, a straight receive it and dump it, okay? And I can see here my SU doing nothing, 15%. All I did in here was increased the number of, kept the same number of messages, but changed myself to a slide-in window. And you can see how there was an increase in my streaming utilization. In here, made my slide-in window larger. So I went from 10 seconds to 20 to 5 minutes to the 10 minute. And you can see now in here, that crept up, but still sitting at the whole 30% mark. So if I kind of try stressing that a little bit, so sending in more messages with a longer window again, now begin to see I'm beginning to hit my usage areas going on. This is a long one. It starts off around 50%. And it slowly builds up over time and up to around about that 1 hour in, which is around the end of my window. You can see I'm sitting there at around the 80% mark. So as I just change my stream and as I just change in my SQL that generates the window and functions, it's stressing my streaming units more. If I was looking at that from the message throughput side of things, these were my 4 operations. This is my straight copy, a straight copy. And then in here, no real stretches going on except at this point where I had loaded up a bunch of events and then I settled down and moved on. So you kind of see there's kind of a flat line going on here of around 40,000 events. So let's stressing this. So this is with 1 TU and 1 SU, increasing the messages, 20 concurrent streams coming in, sending in each one of them sending in 200 messages at a time, sliding window of 5 minutes with a 10-minute max. This is what I see going on, all right? It's handling that volume. But if I look at from the Event Hub point of view, actually what's happened is I'm kind of flatlining around here, all right? This is the max amount of messages I'm taking in on my 1 TU. And if I have a look at my network utilization on my VM, I'm sitting there. That's the amount of data I'm sending out. So if I was to change that and go, well, let's go up to 4 TUs in my Event Hub, same amount of messages, same sliding window, you can see now how my streaming analytics unit has jumped up in its resource utilization. So in the first picture, it was able to handle the volume coming in because that's all the Event Hub was taking. All right. Now that I increased the Event Hub, there's a lot more stress coming onto it. However, on the sender, send it into the Event Hub, my also utilization has gone up as well. All right, so the Event Hub can handle more volume in there now. So now it's taking that volume, so I can send more data to it. And in the meantime, my streaming unit now is going, well, now I got to do more work because there's more data. Bring that up to 3 TUs and 1 streaming unit. My resource utilization from the streaming point of view drops from a flat line down to a more regular repeating pattern where it does go up high but then drops down, goes up high, drops down. And on the but interesting enough, on the Event Hub side of things, I get a further bump in throughput performance. Why? Because the streaming unit is able to take more data from the Event Hub in a better way. So you're playing a balancing game between TUs and the SUs to find your kind of optimal load point in there. There's an interesting blog up on DevOps or DevLogs, where a guy puts together a reference architecture for 1 billion events a day. And basically it becomes a numbers game, all right? He just breaks it down and can go, well, if I take 1 billion events a day, that's 700,000 events a minute, 12,000 events a second, and I'm going to allow for a peak of 1.5. So he's saying, well, I'm going to have 18K events a second. That's what I need to handle. That turns around, this is, well, if 1 TU can take 1,000 events, so for 18 TUs, for 18,000 events, I'm going to need 18 TUs. Looking at it from a multiplying factor, let's pretend each message was 250 bytes. Then if you had 18,000 events, that would give you 4.25 megabytes. That's well within 18 TUs capacity. So you do your little bit of maths at the start to try to scale it. You take an SU, 1 megabyte, so arguably you need 5 of them to consume. But allowing for the query type and scale, you would do a start with 6. And that's the recommendation from the blog. And also, depending on there's also a recommendation in here too about the number of partitions you create. So you'd end up with a picture that looks like this. You'd have 18 TUs, you'd have 6 stream analytics job, maybe going into an Azure database, and the cost of the running that is going to cost you $422 and $525 per month. So just around beneath $1,000 a month to run an architecture that could handle 1 billion events a day, depending on how complex your stream analytics analysis was. Okay. So, summary and conclusion. Certainly capable of spinning up a solution that can handle 1 billion events a day, and more actually, because actually if you need beyond those limits, you can get beyond those limits. There are limits that you can just automatically give yourself. You can open up some support requests with Microsoft if you need to go past that capacity again. Okay, so you can quickly spin up something that could handle 1 billion events a day. Certainly quick to build. I mean, the only real dev in this was my stream analytics function, which was a bit of SQL statement in there. Okay, so very much quick to build. Particularly from a scaling and cost per unit, very easy to kind of size and to scale in there. When I was working with a client who was kind of who had this type of need, and we didn't have the stream analytics option, kind of always lived in a little bit of dread of, if they added on a huge amount of volume, how would you actually handle that in the way we were doing it? Okay, whereas in this scenario, it would be very easy to scale it up. To Azure database, etc. So that's pretty much it, really. That's kind of my conclusion on this whole thing. Stream analytics, it works. You know, it does what it does. A quick look back inside my portal, just to see, have I noticed an increase now side here at the moment? We page those jobs. Yeah, so you're actually noticing, since I bumped it up in there, since I bumped up my event hub, I'm now getting a lot more messages coming in, but actually my utilization percentage is still fine. So that volume of messages comes in, it can handle on its existing utilization. If I wanted to start stressing that, I'd have to start changing my window and functions to add on longer periods of time, and then we would see definitely an impact going on the utilization job. All right, guys, that's the end of my session. I hope you found it of use. We've got a couple of minutes. If you want to ask any questions, pop it into chat, or to you, Daniel. Hey, Daniel.
Hey, so thanks. That was fantastic, because it gives me a couple of connection points to a project I'm working with currently, which doesn't involve any stream analytics, but may very well be a good fit. And I think my client could have saved thousands, if not tens of thousands of dollars per month on this.
Wow, interesting. Yeah. I mean, and the event hub itself is kind of quite an interesting little technology in its own right, because it's such a simple thing, but it does it very well. You know, even just and actually, you probably know Steph Locke, but I was chatting to her recently about in there, and she touched upon kind of streaming a little bit, and I straight away, how did you do that? How did you approach it in there? And in their case, they use the event hub. No, they didn't use the stream analytics side, but they used the event hub, because really it transpired in their case, they didn't really need streaming. Okay, they just needed to capture data, and they could analyze it at another point in time. Okay, now I think in the end she used Azure functions to do the analysis. All right, but she used the event hub as the capture point. All right, send it into capture point, and when you go to the standard event hub, not the basic, but when you go to the standard event hub, you have an option that the event hub can also write down to blob storage. Okay, so as it receives the messages, it just goes chuck it onto blob, chuck it onto blob. So that's all she actually used the event hub for. All right, it says, all right, here comes a message. It was a good way of receiving the incoming traffic, and then just put it onto blob storage directly, and then brought in Azure functions as the way to kind of go onto it. Right, so it's quite interesting in its own right as a way, and the fact that when you take stream analytics, can hop from one event to another event hub, you can kind of see how you would kind of build up some interesting chains if you wanted to go that way.
Yeah. Also, the thing that really speaks to me is the buffering aspect, where if you turn the service off, you make a production change, or there's just too much ingest data, it sort of stores those, it buffers that and catches up, which is kind of hard to achieve if you have a traditional, say, relational database backend, where the database just says, whoa, and then something or other, the application or the database or something, will just crash on you.
Yeah, absolutely. And in fact, I thought while we have a couple of minutes, I have a couple of slides from another streaming than I did, where you kind of go a bit deeper into this type of stuff in there, right? And I'm trying to remember what it is in there, because there's a specific there's basically a guaranteed delivery associated with that in there as well, all right? So with that message and with the stream analytics, I think it's, if I remember correctly, I think it's a guarantee to take the message, although there is the risk that there could be a double write of the message out in there, all right? So if you are going looking into some of these things, there are certain things you need to kind of check into, okay? I'm flashing through this presentation now as quickly as I can to see, can I find it? Well, since I've done this one, that's all my scale stuff. That's my windowing functions. The windowing functions are funky. And I think that's one of the great things about the stream analytics job in there again, is that it actually, from a code point of view, you're not writing much. You know, it is very much, you can just get it set up in here. Yeah, okay, here, exactly once event processing. Yes, so there are those terms around streaming about exactly once event processing, exactly once event delivery. The way stream analytics does is it guarantees at least once event delivery. All right. So in terms of your recovery, yes, you're guaranteed actually that message will be delivered. There can be a little bit of risk that it might over deliver going on there. All right. So sometimes downstream you may have to take that into account, that like, okay, I might have a double write going on there. No, I've never seen an example of it, but it's in there. So you can get there are deeper parts to this whole side of it, but yeah, it's pretty cool.
As for the database, the output end, is there something like an upsert pattern where you can insert, instead of just inserting rows into a table, can you do upserts, merge statements, things like that, or even stored procedure? How much flexibility do you have there?
Do you know what? Now that's super, because my short answer is I don't know in there actually. All right, I don't know. This is where I go back to my little get out of jail free card, in where I'm a hobbyist in this. I haven't put it into prod, and anything I had to do was purely based upon just insert. All right. So I'll be straight up with you, and I'm not sure with that one. But you know what I'm going to do? I'm going to go in and check into that one, because that's a question I got to get. That's a question I got to get answered for sure.
Awesome. But I love the presentation. So, one thing while I remember it, and I don't want to break Magnus' recording here, but you have some audio ducking issues. So I think when you type on your keyboard, your sound sometimes mutes from the microphone.
Oh, so, okay.
I think it might be a Teams settings.
Actually, just having a quick look at that upsert in there, because it was ringing a bell. So upsert data. Stream analytics. Okay, so in stream analytics, if you use Cosmos DB as a sink, there is an upsert pattern obviously sitting out inside there. Okay,
nice.
So I'm going to take that as a reading in there, that if you're maybe in an Azure database, maybe there's not an upsert pattern that you work onto it. All right. Databricks, certainly as another streaming technology, does have upsert patterns going on there. All right, so yeah, that's the answer to that one. So yeah, I'm going to go SQL Server, SQL Database. No, probably not an upsert, but Cosmos, yeah, you can do something.
Cool.
Super.
Thank you so much.
Thank you guys. Thank you for tuning in. If you do have any questions, feel free to ping them on to me or contact me on Twitter or something like that. All right. So cheers for having me, Daniel.